Good morning. My name is Jamila Bali, a student in the doctorate program of California Intercontinental University. Today, I will be discussing hypothesis testing and the importance of visualization. We're just going to start with the agenda. In terms of the agenda, we'll first look at some key definition. We'll then apply the definitions, learn to four different scenarios. Then we'll look at the key takeaways before concluding the presentation before concluding the presentation and opening the floor to questions. In terms of definitions, there's two main important definitions. First is, what is a null hypothesis? A null hypothesis is a testable theory that is formed in the hope that it can be rejected to support an alternate hypothesis. A null hypothesis is presumed true until statistical evidence proves that it's false. Usually, it is expressed in terms of there being no relationship between the variables or no relationship between changes seen in the sample and the population. On the other hand, the alternate hypothesis is the testable theory that the researcher is trying to prove true. Based on this definition, we can see that it's important that the hypotheses are formulated in a way that is precise, clear, and measurable. Looking at in terms of testing for a mean, if we look at the slide, the research question is, on average, are the widgets produced by the company free of defect? This is an important question for the company. To analyze it, we can ask the following null hypothesis. We can formulate the null hypothesis as the mean is not 0. And the goal here is to be able to reject the mean. So the alternate hypothesis would be the mean is 0. We'll need to do some statistical testing and get a p-value in order to be able to reject or not reject the null hypothesis with more confidence. However, we can get a little intuition if we look at the graph. The shape of the curve is a bell-shaped curve, and we can see here that the mean is 0. There is therefore a good chance that we will be able to reject the null hypothesis. Comparing two groups. Here we have two bell-shaped curves. The blue one represents data for major league teams, and the red one represents minor league teams. Each curve has its own average. If we look at the blue curve, the average is around 0.37. And if we look at the red curve, the mean is around 0.29. Looking at the graph, it does look like the average major league team have more home run hitters than the minor league teams. The mean is higher for major league teams, and the bell curve, and for major league team, which is the blue bell curve is more to the right. We cannot answer the research question for sure at this point. We have to perform statistical tests in order to be able to make a better to be able to make a decision with more confidence. To be able to statistically test it, we can formulate the following hypothesis. In terms of the null, we can say that the mean for major league teams equal the mean for minor league teams. The alternate hypothesis would be that the mean for major league is different than the mean for minor league. If we are able to reject the null hypothesis, that would mean that we can conclude that the mean is different for major and for minor league. Once we've confirmed that the mean is different for sure, we can conclude that major league teams have higher home run hitters than minor league teams, given that the mean for major league team is higher. Looking at efficiency comparison, the research question here is, the efficiency curve of the red and the blue teams were recorded. Do the team have equal mean efficiencies? To be able to answer that question, we would formulate the null hypothesis as the average number served per hour is not equal for the red and blue team. And the alternate hypothesis would be the average number served per hour is equal for the red and blue team. From looking at the graph, we can see that these bell curves have one is more spread out, the other one is a lot more narrow, and the mean seems to be different for each curve. So most likely, the average number served per hour is not equal, but we will have to test it. In terms of correlation testing, the null hypothesis would mean that we would formulate the null hypothesis as there is no correlation between mile per gallon and the van's weight. The alternative hypothesis would be that there is a correlation between mile per gallon and van's weight. Looking at the graph, the points are evenly distributed on each side of the regression line. There seems to be a correlation, but we need to perform statistical tests to confirm that. In terms of the important takeaways, when creating a hypothesis test, it's crucial that the hypotheses that we formulate are testable and measurable. It's also important for us to recognize that we're only formulating the null hypothesis in the hope that we gather enough data to reject it. When using visualizations and visual aids, it assists the researcher in forming sound hypotheses, because we can see how the data is gathered. We can see is it in a bell curve? We can see it is just scattered points. Can we run a regression line through it? By being able to see the shape of the curve or the disposition of the points, the scattered points, it allows also the researcher to be able to determine which would be the best statistical method to use to analyze the data. Thank you again for your time, and now I'd be opening the floor. I would be opening the floor to any questions that you may have. Just before I open up the floor to questions, I just wanted to give a little summary in terms of what we consider a good theoretical framework. That is a framework that we can use to identify relevant variables in a situation. A good framework also explains the relationship among these variables and between the dependent and independent variables. By using hypothesis testing, we might be able to find a relationship between variables, but to be able to draw that there is a causation, there's more things that are required. First, to be able to determine that there is a causation, first we need to determine that a covariance exists between the variables. Second, we need to have precedence, meaning that the independent variable changes and subsequently the dependent variable changes as well. Third, there need to be no other possible causes. We need to be certain that the changes in the dependent variable are caused by the changes in the independent variable. Lastly, to be able to draw causation, we need to have a logical explanation for the changes. I just wanted to mention this because it is very important to know when to recognize that there is correlation and when to be able to draw that there is causations as well. Now I will be opening the floor to any questions that you may have. Thank you.